Hello, Brent Ritchie again. Working on the binomial probability distribution. This one is a little more complex, so we're going to use some different technology, not just a calculator, in order to solve it. And here's why. The question says, assume the male and female births are equally likely and that the birth of any child does not affect the probability of any other. Find the probability that at most you get at most 3 boys in 10. So we want the probability of at most 3 boys in 10 births. So at most 3 would mean 3 boys, 2 boys, 1 boy, or 0 boys. So you see there's 4 different possibilities wrapped up in this. So if we were doing this by hand or even by calculator, we would have to let x equal all these values. N is 10 because that's the number of births. The probability for success is always the same. The probability for a girl is always the same. But x takes on 4 different values. So we would be calculating 4 different probabilities. We would be doing groups of 3. How many different groups of 3 in 10 births? Times, oops, not that. 0.5 to the n to the x, which is 3, and times 0.5 to the n minus x, which is 7. That would give us one of them. Then we would have to do this one. Let me use parentheses, it's a little clearer. Then we would have to do this one. I think you're getting the idea. We would have to do one more. We would have to do this one. So there's 4 separate calculations. Then we would have to add these all up. And down here would be our answer. So a lot of binomial problems are like this. Back in my day, we had tables that were cumulative tables that would add some of these up for us to save us some time, because it really, 4 is one thing, but sometimes you might have to do 50. So that got really cumbersome. But what I'm prone to do now is use one of these online calculators, which I don't think anybody would fault me for that. The one I like to use is this one by StatTrek. And what I like about it is that it gives you all 5 different possibilities. You put the parameters in once, and then it gives you the possibility that, let's put this one in and we can see. The probability of a single trial. So this is the probability of success, which for us is 0.5. That's our x. The number of trials is our n. There were 10 births in our problem, so that's 10. And we wanted 3, 2, 1, 0, right? At most 3. So we're going to start with 3 here, and we'll see how we capture the 2, 1, 0 as well. So that's what we put in. That is our, let's see, where's my, I just realized that I am not sharing my screen, and I apologize. Let me see if I got it now. Here we are. This is the StatTrek. This is what I was talking about. These are the values I entered. This is my probability of success. We call that P. This is the number of trials. We call that N. And this is the number of successes. We call that X. Now this is going to save us some time, because it's going to calculate this for X equal to 3, 2, 1, and 0. And let's see, we do that by clicking the calculate button down here, and we get all these probabilities. Now you need to look at these things right here and determine which one of them fits our problem. This is, the first one is the probability of, it says equals. So that would be exactly 3, equal to x, equal to 3. This one would be less than 3. So this one would be exactly 3. This would be less than 3, which would be 0, 1, and 2. That's not what we want, because recall we want 0, 1, 2. Oops. 0, 1, 2, and 3. That's what we want. And that's not less than 3. Less than or equal to 3. There we go. This one, less than or equal to 3. That's going to give us the probabilities for 0, 1, 2, and 3. So this is the value we're looking for. And then, of course, you can see this is greater than 3, and that's greater than or equal to 3. So every possible, when you put that 3 in there, it calculates 5 probabilities for you, which is every possible option that has to do with 3 and 10. So then it really just becomes a challenge of picking the right one. In our case, it's less than or equal to 3, 0.1718%. While I'm here, let me try it again. The test consists of 10 true-false questions. Clean that up a little bit. To pass the test, a student must answer at least 8 questions correctly. If the student guesses on each question, what's the probability that the student will pass the test? So the student needs at least 8 out of 10. That means greater than or equal to 8, because in order to pass this, you would need 8, 9, or 10. So we're looking for greater than or equal to 8. So when we put our new values in here, the greater than or equal is the one that's going to have our probability in it. And they tell us these are true-false questions. So, and how many are there? There's 10. So our N is 10, total trials. Our X that we're starting with is 8 correct. The probability of success is 0.5. When you're guessing on true false, that's your probability of success. And you'll notice that this calculator does not ask for the probability of failure, and that's because it can calculate that itself. It doesn't need you to subtract from 1 for it. It can certainly do that. So you only have to put one of those probabilities in. So there we go. We put in the new probability. Now this thing does not recalculate on its own. You have to hit the button. And there we go. We know we want the greater than or equal to. So that becomes this one right here. So about 5.5%. So if you're trying to guess your way through a true and false test that's got 10 questions on it and you need 8 or more right, you have about a 5.5% chance of pulling that off. Not a very good chance. All right, we'll come back in another video with some more binomial probability distribution questions.